Hi, I'm Munira and I'm going to be giving the introduction. Radio waves are a form of electromagnetic waves. Electromagnetic waves are split into a range of frequencies, which are called wavelengths, and this is known as the electromagnetic spectrum in increasing frequencies like radio waves, microwaves, infrared radiation, visible light waves, ultraviolet radiation, X-rays, and gamma rays. Radio waves are commonly used in communication and information technology. They are used in radio and television communication systems and also in cellular phones to transmit voice communication in the ultra-high frequency band. They can be produced when the electric charges start to move back and forth to create an accelerating electric charges until they are able to travel the speed of light. Since radio waves can travel long distances, they are used in everyday technologies. The examples are radio, mobile phones, and satellite communication. This had made wireless communication an important part of the modern life nowadays. Next is significance. Radio waves make wireless communication possible by allowing information to be transmitted over long distances without the use of physical cables. Next, it is an essential in daily use such as radio and television broadcasting, mobile phone communication, Wi-Fi, and satellite system. Thirdly, it is widely used in navigation, radar, and GPS system. It helps in transportation, weather monitoring, and also location tracking. Lastly, it also plays a crucial role in modern communication and information technology by enabling fast, reliable, and global connectivity. Next is the relevance of electricity and magnetism of radio waves. So radio waves can be produced when electric charges oscillate during an alternating current flow through a transmitting antenna. So this will create a continuously changing electric field. Secondly, electrical signals contains information such as sound, images, or data. They are converted into radio waves by electrical circuits and transmitted through antennas. Third, radio waves will reach a receiving antenna. Then they will induce an alternating electric current and be processed by electronic components. This is to recover the original information. Lastly, the changing electric field generates a changing magnetic field. They propagate through space as an electromagnetic wave carrying electrical energy wirelessly. The formula stated here can be used to see how speed of light, frequency, and wavelength ties to each other. So in detail, the frequency of a radio wave determines the type of its signal. The wavelength affects how far it can travel and how it interacts with objects, and also antennas can work as a converter from an electrical signal into radio waves. So they are for the transmission and convert receive radio waves back into electrical signals.
Let us look at how radio waves are used in real life. Radio waves are widely used in radio and television broadcasting to transmit audio and video signals wirelessly to homes and vehicles. They are also essential in mobile phone communication, where radio waves allow us to make calls, send messages, and access the internet using 4G and 5G networks. Radar systems also use radio waves to detect aircraft, ships, weather conditions, and vehicle speed. Another common example is Wi-Fi and Bluetooth, which use radio waves to connect devices such as smartphones, laptops, headphones, and smart home systems without using cables. Lastly, radio waves are also used in satellite communication such as GPS navigation, weather forecasting, and global data transmission between satellites and Earth. There are several benefits of using radio waves. Radio waves enable wireless communication without physical cables, which makes communication faster and more flexible. They allow long-distance communication, allowing global communication through satellites. Radio waves support high-speed data transfer, which is important for video calls, online learning, and streaming. They are also widely accessible and are used in many everyday devices such as smartphones and radios. In addition, radio waves play an important role in emergency communication systems, especially during natural disasters such as police and ambulance. Radio waves also have some challenges. One challenge is signal interference, where buildings, weather, or other electronic devices can weaken the signal. Another issue is limited frequency spectrum, which can cause network congestion when many users are connected. There are also security concerns as wireless signals can be intercepted if not properly protected. Some people are concerned about health effects, although radio waves are considered safe when used within international safety limits. Lastly, the cost of infrastructure, such as setting up towers, satellites, and network equipment, is very high cost.
Future developments of radio waves. Radio waves are constantly evolving to meet our growing need for faster and smarter communication. Here are the key future developments. First, development of 6G and future wireless networks. Next generation networks will provide higher speeds, more reliable connection, and support advanced applications. Second, use of higher frequency radio waves. Higher frequencies allow more data to be transmitted over shorter times, increasing network capacity. Third, faster data transmission and lower latency. Communication will be almost instant, enabling real-time applications like virtual reality and autonomous vehicles. And last, Internet of Things and smart technology. Radio waves will connect everyday devices like smart homes, wearables, and industrial sensors, making life more efficient. Satellite and space communication. Radio waves are essential for communication beyond Earth, enabling global connectivity. Like radio waves used for satellite communication, satellites rely on radio waves to send and receive signals over long distance. Next, long-distance signal transmission. Radio waves can travel vast distance, connecting remote areas without physical cables. And last, global internet coverage. Satellite networks aim to provide internet access worldwide, even in isolated regions. In conclusion, radio waves are essential in modern communication, serving as a backbone for mobile networks, broadcasting, and satellite systems. As a key application of electricity and magnetism, they demonstrate the practical impact of fundamental physics in everyday life. Radio waves offer faster, more reliable communication and global connectivity, though challenges like interference and limited spectrum remain. Future developments, including higher frequency waves, 6G networks, and advanced satellite systems, promise greater speed, efficiency, and coverage. Radio waves continue to play a crucial role in advancing global communication technology.